So today what we're going to do is we're going to look at factorizing. And for most of you, this should be review. And if it's not, it's fine, because I'm going to do it as if you've never seen it before. Okay? So if you've seen it before and you're happy with it, then this will be an easy day for you. If you've seen it before but you never could make it work, this should be a happy day for you. Either way, right? So we're all good, in good shape here. Here we go. So, factorizing polynomials. Now, we've discussed that word polynomial before. A polynomial is just a collection of terms, right? Remember, the difference between algebra and arithmetic is the idea of terms. The introduction of the letters makes the building blocks of algebra bigger. All terms have exactly how many parts? Anybody? 4 parts. What are they? Sine, coefficient, base, exponent. Exponent. There you go. Okay. So the first part of every term is it's what? Sine. So every time you see a sine, you know you're talking about a new term, right? That's going to be very important when you're factoring, because you need to know how many terms there are, because that's going to determine the method that you use for factoring. Okay? So factorizing polynomials. The first thing is always count the number of terms. Now again, because the number of terms that you have is going to determine the method you're going to use. Okay? Now, no matter how many terms, however, so no matter how many terms, the first step is to look for the greatest common factor, which from now on I'm always going to abbreviate as GCF. So, right? The greatest common factor. Now, a factor means anything that will divide evenly, right? Because factors are things you multiply together to get new numbers. So that means you're looking for factors you're going to be dividing. So factor means anything that divides evenly. If it's common, that means it occurs in how many of the terms? All of them, right? If it's common, that means it has to occur in every term. And if it's the greatest thing, it has to be the biggest thing possible. So if all the numbers would divide by 2, but they would also divide by 4, dividing by 2 is not good enough, right? You have to divide by 4. Make sense? No big deal. So let's talk about finding the greatest common factor. But first thing I want to show you is this word. I didn't say find the greatest common factor. What did I say?
Look.
If you look for something, do you always find it? No. Most of the time, there will be no common factor. Most of the time. But if there is, and you miss it, everything you do after that is wrong. So you have to look for the greatest common factor first. Okay? Right. Now let's talk about what that means. Okay? The greatest common factor is anything. Oh, wait a minute. Don't write anything. I'm so very sorry. Very sorry. Very sorry. I don't want anything. I want the largest thing. And again, I'm saying thing on purpose because it can be any combination of stuff. The largest thing that will divide evenly, that should go without saying, but I'm going to stick it in there, into every term. Okay? The largest thing that will divide evenly into every term. And there's the key. It has to divide evenly, and it has to divide into every term. And, of course, it must be the largest thing. That's the word greatest, right? Okay? It can be a number. All the terms might divide by 8. Okay? A letter? There might be an X in all of them. Okay? Both? Meaning a number and a letter? Or even, thank you for that, or even an entire bracket. And that's a special case, but you're going to see it. Right? Now, if it's going to be a bracket and it's a common factor, what do you think has to happen about that bracket? If it has two sets of brackets, they have to be, what do you think? Well, not multiplied together, but they have to be identical. Okay? They have to be the same factor, right? So if you have a set of brackets, the brackets must be identical. And we'll focus on that in a minute when we see it too. Okay? So, common factor can be a number, a letter, both, or an entire bracket. The bracket is the easiest one to do because all you have to do is see if the brackets are the same. Boom, they're done. Right? But it's also the weirdest one. It's the one y'all are going to look at and go, wait a minute, what's going on with that? That's got a bracket in it and I need to multiply it out. You don't. If they're identical, don't multiply it out. Make it your GCF. Okay? So we're going to talk about factorizing what are called trinomials. Now, a polynomial is just any collection. Shh, guys, recording. Polynomial is just any collection of terms, yes? Yes. But a trinomial is very specific. It has exactly, what do you think? 3 terms. Good job. Okay? It is the most common type of polynomial that you're going to have. Okay? And it requires a process to factorize. Right? No. Okay? All right, so here we go. So let's talk about the steps. First, you're still going to look for what, you think?
GCF.
GCF, there you go. Just for GCF, and that is the first part of finding the GCF. So look at the first term, sign to the first term. So look for a GCF. That never goes away anytime you're factorizing anything. You always do that. And sometimes that's all you can do, and sometimes it leads to more stuff. Okay? You can still do other stuff. But you always look for the GCF first. Notice again, though, I write look. Why? There might not be one. Okay? Good job. All right. Second step. Okay? Now, before I write the second step, I want to remind you, because you've all seen the quadratic formula before, yes? Maybe? Somewhere? Yeah? Okay. Well, a trinomial always comes in exactly the same form. The general form of a trinomial is ax squared plus bx plus c. Now, if you haven't seen that before, don't worry about it. It's no big deal. All right? But you need to know it now. Now, let me just talk you through this because it makes so much sense. It makes all the sense in the world if you'll just listen. First of all, what are the first 3 letters of the alphabet? A. Does A ever come other than first? No. It's A, B, C. So notice, the first one is A, the middle one is B, the last one is C. So are you ever going to get those out of order? No. A, B, C. Notice that the first X is X to the what?
Square.
Second power. Then there's just plain old what? X. And then what do you notice about the C term? There's no X in it at all. Right? Now, it can have, guys, come on. It can have a variable in it, but we'll cross that bridge when we get to it. I don't think they're going to take you there for what we're doing. Okay? Because it'd be impossible to solve the equation if it does. Okay? So, A, B, and C are numbers. And they'll change depending on what you have. But x squared is always going to be just what? X squared. X is always just going to be plain old x. And the last one is just going to be a number. It's not going to have an x in it. Okay? And I'll write down plenty of examples of this. All right. Now, so if I say B, I'm talking about the number where? The second one in the middle, the number in the middle. If I say C, I'm talking about the number where? At the end. If I say A, I'm talking about the first one and its x squared?
No.
Just A is just the number, right? So be careful. Remember, they're not the same thing. It's not, so it's ax squared. If I ask you for just A, do I want the x squared part?
No.
Nope. I just want the A part. Does that make sense? Okay. Now, grasping that is half the battle. So if you know what I'm asking for. So I'm just going to write an example here. So say I write 4x squared minus 3x plus 2. How many terms is that?
3.
So it's a trinomial, right? Good. Can anyone tell me what A is here?
4.
4. And it's actually a positive 4. Be careful about your signs. So remember, we always say positive or negative in this class. What's my B?
-3.
What's my C?
+2.
How hard was that?
Not hard at all.
There you go. If you can do that, then you're setting yourself up to be able to work this, to be able to factorize these.
What if it's in will it be in brackets either?
No, won't have any brackets in this one. If you do, you'd have to multiply them out. Yeah, so it's a different form. Okay? All right. So first thing you do is look for a GCF. Second thing you're going to do is you're going to multiply. You know what? I'm sorry. I know y'all hate me for this. I know you hate me for this. But I know where you all are, and I really want to say it. I'm going to tell you the second thing you need is list A, B, and C. Now, technically you don't have to, but for most students, it just makes your life easier if you do. Okay? So do that. Third step. Multiply A times C. That just means the first number times what?
The second number.
The last number. It's all right. Okay? First one times the last one, right? Okay? Now, when you do that, we're going to call it AC. Because if you multiply A times a C, you would just get AC. It just puts them together. Now, but in reality, it's going to be a 12 or a whatever. In this case, it would be 4 times 2, which would be an 8, positive 8. Okay? But do watch your signs. Don't write anything down without its sign. So make sure you're very careful. What did I say earlier? The most common mistake in algebra are sign errors. And so be careful. Okay? Then, fourth step. List factors of AC. Now, AC is that number I got when I multiplied my A times my what? C. Now, don't worry about this one because this one will not work. The example I wrote. So I'll have to get you another example in a minute. Okay? But list the factors of AC. Factors means anything that divides in how? Evenly. Okay? So list factors of AC. Now, you need to think of two things here. You need to list them in order. And when they're numbers, what do I mean by order? 1, then what? 2, then numerical order, right? List them in order. And when you're listing them, you need to remember that factors always come in pairs. 8 is 1 times 8. So the two factors are 1 and 8. And what? 2 and 4. Will 3 go into it? No. And I don't need to try 4 because it's already on my list. Right? 2 and 4. So you'll know when to stop as long as you go in order. Okay? So does everybody see what I'm saying? Why do they come in pairs? Because if you're multiplying, you have to multiply at least two things together, right? Otherwise, you're not going to multiply. And you need to do them in order so that way you know when to stop. Okay? Now, in the beginning, we will list every factor every time. But as you get better at this, you're going to start seeing what the pattern is, and then you might not have to list every factor. Because it can be time-consuming, but it will not hurt any of you because some students, nobody in this class, but some students don't know the multiplication tables very well, so the practice will not hurt them. And that's nobody in this class. Y'all are all perfect and good. All right. Now, we want to find the two factors of AC. So that's the list we just made, right? And they two factors because they come in pairs that combine.
Add? Is that?
Yeah, you bet we've used that before. Remember, combine means add or subtract, though, right? Because remember, it depends on the signs. Combine is the algebra word for putting things together. Add or subtract, depending on the signs, right?
Yes.
That combine to make B. And again, I'm going to tell you, look at the signs. Be very careful about the signs. Now, I'm going to walk you through this process, and we're going to take a few notes because I want you to be aware of what's it's a process, and it's a thinking process if you'll go through it. Okay? All right? Does everybody have this written down?
Yes. Wait, hold on the last one.
Okay? So find the two factors of AC. So that pair of factors that will combine. What does combine mean? Either add or what? Subtract to make what thing?
B.
B. And remember, B is going to be a number in the middle and it's going to have a sign, right? So you have to make sure they combine to make the right sign. So this is going to give you lots of practice with the sign rules. Okay? All right, here we go. To do that, ask yourself, add to make B? And this will make sense in just a second.
All right.
Then
add to make
subtract to make B? Signs still work? Those are the three things that you're going to be asking yourself about each one of these. Okay? All right? And again, we're going to do tons of examples of these, but I just want to keep everything in order. Okay? Now, what was up? 5. Okay. Step 6. Are we ready? Come on. Replace the B term. Oh, the B. I'm so silly. The B term with those two new factors. Don't forget the X, because your B term has an X in it. So replace the B term with those two new factors. So whatever factors you just found, factors of AC that will combine to make B, you're going to replace B with those two new numbers. But remember, it says replace the B term. So we're not just talking about the B, it's also going to need its X in it. And you're going to see plenty of examples, so don't panic yet. Right now, right now, I want you to tell me if there are any words you're not understanding. Don't worry if it's the process that's worrying. Don't even think about the math right now. Just think about what I'm saying. Where's the B term? The one where?
Middle.
And we're going to replace that one thing with what? Two things.
Don't forget the X.
And we're not going to forget that it's not just a number. The B term also has a what in it? An X in it. Okay? So just right now, I just need you to know that you understand what I'm saying in the wording. Okay? All right. Step 7. And yeah, there are a lot of steps. This is the most complicated thing you're probably going to do. All right. Okay, here we go. Split the new polynomial in half. And it always breaks in the same thing between the two new numbers. So it's always you split your B in half, right, or into two pieces. You're just going to split the whole thing into two pieces. Okay. So. There's no math there. What I usually do is I just draw a line. Or some students will just leave a space when they rewrite it because you're going to have to write it down. When you write it down, you just leave a space. they're all aligned, leave a space, do both, I don't care. And again, you're going to see it. But between those, we picked two new numbers for b, right? We're going to break it in half between those. Because think about it. If I started with 3 terms and I broke my b into 2 terms, how many do I have now?
4.
So I've got the first 2 terms separated from what? The second 2. That's what I mean by splitting it in half. Okay? 8. Find the GCF in the first group. Because what I've done is I've just made 2 groups of factors. Okay? I'm going to find the GCF in the first group. Now notice I didn't use the word look this time, did I?
Find it, there will be one.
Yep. If there's not, then you've done something wrong.
That's good.
Okay? So, it doesn't say look this time, it says find. Okay? I'm going to continue the notes on this side and we'll do some examples. 9. I know it's a lot of steps, guys, but it's harder to write down and explain than it is to do. Bring down the sign of the third term. That's the term right after the break. It just comes straight down. Don't change it. Don't pay attention to what the book says. The book says try it as a negative, try it as a positive, and see which one works. It's always the sign of the third term. If the third term is negative, then you need a negative. If the third term is positive, then you need a positive. You do not need to go through any worry about that. It's always the sign. I don't know why math books always make you decide you have to find or discover something when they could just tell you it's going to be this. But they do. So don't worry about it. And if you go to another math teacher, they're going to say, okay, you should try a negative, and then you should try a positive, when you know it's going to be just whatever sign it is. Okay? Then, find the GCF. Oh, yeah, there's going to be an 11. Find the GCF in the second group. Now, notice, it doesn't say look, it says what? Find. Well, all you're doing is finding GCFs. That's the factorizing part, right? Okay. Find the GCF in the second group. Now, notice it doesn't say look. It says what? Find. And this is the weird part, guys. Even if it's just a 1. Usually we never divide by 1 because you get right exactly what you started with. But you have to divide out something, even if it's just a 1. Okay? So if there's nothing common to them, what's common to everything? 1. Normally we would never divide it out, but here we have to. It's a 12-step program, kids. All right. Now, remember, when you find the GCF, you're going to put the GCF and then open up a bracket and then do the division, right? Well, if I did that twice, how many sets of brackets am I going to have? 2, right? The brackets must match. They have to be identical. And if they're not, then either 2 things. Either you did something wrong in your math or it won't factor. But these are going to factor. Okay? For right now. All right, the ones I give you are going to factor. So the parentheses have to be identical. And that's why we have to find a GCF in both of them, because if you don't find a GCF, even if you divide out of 1, you're not going to end up with two brackets. Yeah. You get a bracket by dividing out a GCF. Second, here's how you're going to write it. Now, this is difficult for me. I always struggle with telling you how to write this, but it's okay. So what we're going to have is you're going to have some A. I'm not going to write A. I'm going to use X because I don't want to confuse you with A. Some X in front of Y plus Z plus some D in front of E plus F. Okay, wait a minute. No, can't do that, can I? All right? What do you notice about the 2 sets of brackets? So, didn't we do an example that looked just like that?
We sure did.
Right? So what we do is, you simply factor out
Oh. Wow.
the common bracket. In no particular order. Yeah, I know. When you say common, you all got to like the denominator. All right? Okay? Now, I know there are 12 steps, but I wanted you to see them in pieces instead of doing like one step with A, B, C, D, right? There is no quick and easy way to do this, but it becomes a habit. Do you maybe walk somewhere ever?
Yeah.
Okay. Do you only take one turn everywhere you walk?
Sometimes. Yeah.
Everywhere, I said. Sometimes you have to do more than one step. Okay? Now, so we'll do number 4 first, because we do the evens. We do the evens, you do the odds, right? Page 45. The step only puts it as 6 steps, but they combine a bunch of stuff. And they assume you know a bunch of stuff, and I don't. All right, here we go. 2x squared minus 5x minus 12. Now we're told to factor this. What is the first thing we do when we're factoring anything?
GCF.
Look for a GCF. That's anything that'll divide how? Evenly into what? Every term. Is there anything in common to 2, 5, and 12?
No.
Is there an x in all of them?
Yes. No.
Not in all of them. So is there a GCF for everything? No.
Oh, this is a trinomial.
Yes. How many terms do we have? 3. So first, look for the GCF. We don't have one. Then, we need to know how many terms, the number of terms. How many terms is this?
3.
Trinomial. So we're going to use what's called the AC method. And just because it's such a genius name, because what's the first step? Multiply A times C. And that's the thing about math. So first thing is we're going to multiply A times our C. So what is my A?
2.
What is my C?
12.
You just failed.
Negative 12.
Thank you. There's no such thing as a number without its what? Sign. So my A is 2, my B is negative 5, and my C is negative 12. And that's why I wrote make a list. Because if you make the list, it forces you to think about it. Yeah? Okay? Make a list. So multiply my A times my C. So 2 times negative 12 gives me what, guys?
24.
Negative 24.
But in this.
Then I'm just going to start listing things that multiply together to make 24. Right? 1 goes into 24 how many times?
24 times.
Good. Will 2 go into it?
12 times.
Yep. How about 3?
8.
How about 4?
6.
How about 5?
Nope.
Do I need to try 6?
No, because it's the opposite of 4.
Because it's already on my list, yeah. Right? So as long as you go in numerical order, you know when to stop. Okay? All I did was simply divide. 1 goes into 24 times, 2 and 12, 3 and 8, 4 and 6. Are we good? Okay? Now, I need to find the 2 factors of that
I know what they are.
that combine to make what?
5. Negative 5.
Yeah, and watch those signs to make B. Yeah.
Oh.
Okay? So, if you add, now this is what I gave you. I said add them, subtract them, and watch your signs. Now, follow along with me, guys. Everybody, listen. If you add 1 and 24, what do you get? 25. Is that what I'm looking for? No. If you subtract them, they make 23. Is that what I'm looking for?
No.
So I know that combination. So that combination isn't going to work. Yes, I know, but I'm still walking through. Okay? 2 and 12. If you add 2 and 12, you get 14. Is that what I want?
No.
If you subtract 2 from 12, you get 10. Is that what I want? Nope. So that won't work.
Who do you subtract first?
3 and 8. If you add 3 and 8, you get what?
11.
Is that what I want?
No.
But if I subtract 8 and 3, I get what?
Negative 5.
I get 5. Well, hold on a minute. I get 5. Right? Okay? So, the next thing I said is be careful about the signs. Right? Guys, come on. In order to subtract, what do I know about the signs? Do they have to be the same or different?
The set.
Different.
They have to be different, right? In order to subtract numbers, the signs have to be different, right? And what sign do I want my answer to be?
Negative.
So that means one of them needs to be negative which one?
8.
The biggest one. So negative 8 and positive 3.
Oh, so you can't do.
Okay? But remember I said you have to check those signs. Does a positive 3 times a negative 8 still give me the negative 24 that I started with?
Yes.
Then I'm good to go. Okay? Now again, let's go back. I can't add 8 and 3 because that gives me 11. I can subtract them. In order to subtract, the signs must be what? Different. And since I want to get a negative, remember that it's subtract and keep the sign of the larger number, the bigger number. So the 8 has to be the negative. But I still have to make sure to check those signs to make sure that combination still gives me the negative 24. Because you can find combinations, not in this case, but in some combinations that would work, but not with the sign, but the signs would make it not work. Do you see?
Yeah.
So we have to check it twice. They have to make B, but they still have to multiply together to give you the thing you started with. Okay? Now, okay? So my two new numbers that I'm going to be using are positive 3 and negative 8. And I'm going to use those to replace what? Well, the b term, right? Okay, the minus 5. So will 2x squared change? No. Negative 5x is not going to be negative 5x anymore. It's going to be what? Positive 3x and what? Negative 8x. Notice I left a space there. Get in the habit of it. And then will my c change?
No.
No.
What's the space?
So all I did was replace that b term with those two things, making sure that when I did that, I put the x back in. Right? So the math is very easy, but the signs are the part that's going to.
There wouldn't be.
Now, the reason I left a space there is because the next step is to break them in half. You don't have to leave a space. I just usually leave a space, and I'm doing it for effect here because y'all I'm teaching you. Then, now all that's required is to find the GCF. So now we're back to GCF. After we split it in half, then it's all about GCF again. So, anything common to 2 and 3? Is anything common to x squared and x? X. So let's divide out in x. 2x squared, divide out x, what's left?
X.
2x.
I mean, you'd already written the 2.
Oh, okay. Good save. Positive divided by positive is positive. 3x, divide out the x, you're left with what? 3. Do you see this sign right after the break?
Negative.
That's the third term. What sign is it? That means you need to bring down that negative. Don't ever think about why, just bring it down. Okay? What's happening is your first term is your first factor is negative, therefore your GCF has to be negative. What's common to 8 and 12? 4. Is there an x in both of them? No. So let's divide.
8 and 12.
Negative divided by a negative is a positive. 8 divided by 4 is
2.
x divided by nothing just stays
X.
x. Negative divided by negative is a
Positive.
12 divided by 4 is
3.
close your bracket. And what do you notice about the two sets of brackets? Which means that they are a common factor.
Now we got the same thing.
So it's going to be 2x plus 3 in the first bracket and what?
Oh, X minus 4.
X minus 4 in the second one. Now, would it matter if I reversed them? Nope. As long as the stuff in the bracket is the same, it doesn't matter which order you write them in. The book tends to write them in the order at the bottom. I tend to write them in the order at the top, but I don't care. That's your answer.
Wow. It's always ending one of those things. I mean,
Yeah, two sets of
and I
brackets.
did.
Now,
Wow, stuff is amazing.
we are not, guys, come on. We're not quite, we're through with this process, but we're not through with factorizing, okay? So what I'm going to do is I'm going to give you an assignment on this page. Give it a shot. If you can't get the first one to work, go back to your notes and look at your notes and see if you can fix it. If you can't get the second one to work, then stop. I would rather you do no homework at all than to teach yourself how to do it
I
wrong.
would like to get that in mind, please.
Yeah.
I will write it down. I just recorded it. Okay?